Good morning, everyone. Yes, my name is Joakim Nordström. I work at Oracle in the Java group, and today I'm going to talk about the flight recorder and give a programmer's guide to that. I kind of assume you kind of know what the flight recorder is, but if you don't, I hope that after this talk you will know a bit more. And basically what it does is that it records events from the JVM, the JDK, and the applications that are running on the JVM. And it allows you to inspect the entire software stack. The flight recorder is part of the JVM, so you don't have to download any third-party libraries to use it. And it is designed to be always on, so it has a really low overhead, and that it is its purpose to be always on. And this is the agenda for my talk. We're going to look at how we start and stop recordings, how we analyze them, how we can create our own custom events, and also I'll be looking at how we can consume events programmatically, and how we can use events in our unit tests. But we start with how we can start and stop recordings. And the JVM is shipped with two configurations. It's the default configuration that is supposed to be the one you use when you have the flight recorder always on. And like I mentioned, it has low overhead, less than 1%. And then we have the profile configuration. And this you can use when you want to get a bit more information from the JVM. And it can have slightly more overhead, but nothing. But you shouldn't be afraid to run it. There are slightly changed thresholds, so you get a few more events. There are a few more stack traces and so. And these two configurations are in the libjfr directory. And they are ordinary XML files, so if you want, you can customize them. But a pro tip is to not actually change the files, but rather take a copy of the file and then change the copy. I mentioned this because we've seen customers who have changed the configuration and then were surprised that they got weird recordings in a way. So, and if you need to create your own configurations, you can use the JFR command line tool that I will show later on as well for that. But let's start with the always on case. This is how you enable and start a continuous flight recorder when you run your JVM. And this will then create a continuous recording that will always contain the last 15 minutes of events generated by the JVM. You can set this. You can set how much data you want to store during the recording. I believe it's by default it saves 250 megabytes at its max. You can also set a max age so that you always get 15 minutes or what you want. If you add this option dump on exit, then when the JVM does a normal, when it exits normally, you will get a recording. You don't need a dump on exit true if you just want a recording when the JVM crashes. And then there's an emergency dump that will dump the recording. But hopefully your JVM never crashes. The default name is hotspot_process_ID_timestamp, and you can change either you can set the file name to a directory and the hotspot file will end up there, or you can just name it the way you want. And so that was the continuous recording that should always be on. But at times you also want to start the recording during when the JVM is running, and then you can use the jcmd command. And you can use the jcmd command jfr.start, which will start a new recording. You can see here that I've set the settings option to profile, meaning that we will take the profile configuration. You can set this, if you set this to default, you will get the default configuration, and if you set it to a full path, you can use your own customized configuration files. And this will then, you can add a file name so that you know where the file will end up, and you can add a duration. So if you do this command, you can just start it, go take a coffee, and then 10 minutes later you will have your profiling recording that you can analyze. And the continuous recording will continue as it recording, even though the profile recording was stopped. There are also a few other JFR-related commands with JCMD. I mentioned the start. You can also use jfr.dump to write the recording to file. You can use this dump command to also dump the continuous recording. If you use the jfr.check command, you can see all the recordings that are enabled in the JVM. So if you have the continuous recording, you will get one recording there. And if you have started your own recording, you will get 2 recordings there. And JFR stops a recording. And in order to know, if you just run the JCMD command, you will get a list of all the JVMs currently running on your system. And then in order to know which JCMD commands each JVM supports, you just enter JCMD and the process ID followed by help. And there are lots of more commands in JCMD, not just to control JFR. So now that we know how we stop and start recordings, I'm going to talk a bit about some tools that you can use to analyze recordings. The first one is JMC, the JDK Mission Control. It's a graphical interface to allow you to analyze recordings. You can get some nice looking graphs, and you can filter on events and understand what the JVM is doing. It's a separate download. It used to be part of the JDK, but now it's a separate download. Regardless of which JVM version you're using, you should use the latest JMC, which is currently 8. I'll show more about JMC later on in the presentation. There is also a command line tool to work with the JFR recordings. This is included in the JDK. You can list events, you can output them as text or JSON. It's also possible to use this tool to create your own configuration files. You can also disassemble chunks from a recording. For instance, if you have a really big recording that JMC can't load because it's so huge, then you can minimize it. And you can also do the opposite, which is assemble leftover JFR chunks. And the way JFR works is that it stores its recording during runtime in so-called chunks, and it stores these in a repository, like a temporary directory. And if you're really unlucky and your JVM crashes in a bad way, then at times JFR crashes as well with the JVM because your application did something. And then you can use these chunks that haven't yet been written to a recording and assemble them to a recording in case disaster strikes. The newest command in JFR is the scrub, which you can use to scrub events from a recording, meaning that you can, for instance, remove events that contain personal information, or if you just want to filter out a few certain events. So those are two tools to analyze recordings, and now we'll jump into some code and create our own custom event. And in order to have some sort of context for this small custom event that we're going to create, I have created a small business application, and it's a relatively simple thing, but basically the idea is we have a client that sends requests to this business application. The business application has some business logic, and the logic is basically we look at the destination, depending on the destination, we choose a service that we want to execute. Yeah, it's a server application. It's built with JDK 19, so all of my examples will work for JDK 19. Yeah, and this is just a small, what our business logic code looks like. You don't have to look too closely at that right now. We'll come back to that. And the requirements for this business application is that we want to monitor service calls and also catch unhandled destinations. So we start this by creating a plain old Java object. We're going to call it service call event because it's an event for our calls to our services. We add a field for the destination, and we add a service class field as well, so that we can map the destination to which service is invoking the request coming to that destination. And the only thing we need to do to create a JFR event is to extend this class with the jdk.jfr event class. And this is basically all you need, and we have created our own custom event. This will create an event named like package and with a class name by default. But it's always a good idea to add the annotation name, so we create our own name for this event. And this name is supposed to be kind of unique, and we want to use the reverse domain name notation. But you can see that I've removed the monitoring and the event thing from the package name here to make the name shorter, and also this is used in the JFR context, so we know that service call is an event. However, in the Java code, I've added the event postfix to the class just so that it's clear in the Java code that this is a service call event and not the actual service call or something like that. So with the name annotation, you can create a better name. And it also simplifies if you want to refactor your event and move it somewhere or so. And you have to think, depending on what you're doing, is it your own internal business application? You can name it like you wish, but if you're creating a framework, it's good to think about what you name it so it doesn't clash with other frameworks or so. It's also possible to add a label, and I urge you to add a label. This is supposed to be in human readable form. It's capitalized. You can see I have a service space call, so it looks good and it's human readable. And we can add these annotations to the fields as well. So to our destination, we add a label, service destination. I haven't entered a name here because I think the field name destination is fine. But you see for the service class, I removed the weird impl thing from the JFR name. Just to hide some of our internal things in our application. We can also add a category, and this will create a hierarchy. So this event falls under our business application and under the service category. And this is also supposed to be in human readable form, unique, descriptive, and so on. We'll see how this event will look when we analyze it later on. So, but now we have our own custom JFR event. So let's add it to our business application. And here we have our business logic. We have some sort of method lookup service that takes the destination. If the destination is comp3, we just create a new upload image service or whatever, and then we return the service. And we add our JFR event here. We create it, we set the destination, and then we call the begin method. And this begin method is from the jdk.jfr event class. And this is what sets the start time for the event, so we know when the event started. And then when we have determined our service, we set the service impl class field to the service, and then we call the commit method. And this commit method is also part of the JFR event class, and this is when the event is actually committed to our recording. So we also wanted to catch unhandled destinations, so we add a default case here, and for the case unknown and the default case, we add our other custom events called unhandled service call event. We set the destination and we commit this event instead. And since I'm returning null here, we won't commit the service call event for this unhandled service call. So for each destination, we will either have a service call or we will have an unhandled service call. And that's basically it you need to create and add a custom JFR event to your application. So we're going to step back one step and analyze a recording that contains this custom event. So we start JMC. We open this recording that our server has created using our custom events. We go to the event browser, and here you can see our lovely little business application category. Below it we have like the flight recorder, Java application, JVM and operating system categories. And these are the events that you get with the JVM. But the top one is our custom event. And if we expand that, we get to other categories, data and services. And it was the service category that we just added in our custom event. And under the services category, we have our service call and our unhandled service call. And if we compare this to our Java code, we can see how the different annotation maps to what we see in JMC. So we have the category that builds the hierarchy. We have the label that shows clearly what kind of data we're looking at. And if we click on the service call, we will get a list of all of the service call made. So we see the start time, the duration, the end time, and event thread. The 4 first columns are default columns that you get when you create a custom event. And then the 2 second, the service implementation class and service destination are our own custom fields. We can also see the stack trace at the bottom here also. It is also possible in JMC, I'm just going to show this briefly, create a custom page, and then you can mark the events that you're interested in, and you can group them. So here we can see that we're looking at a particular event thread, and we can see all the events that have happened in that thread. So we see the data upload, which is a custom event made up by our business application, and the service invoked is also from our business application. And then when this service was invoked, we apparently did some file write, and that's a JDK event that is emitted when we write to a file or so. So you can see that we both can see our own application as well as what the JDK does. So yes, now we created our own custom events and we've implemented them, we analyzed them. Let's consume some events. We can do this programmatically, and I'm going to show these 4 classes. We have the event stream and we have the recording. These are what were added in JDK 9. And we also have the recording stream, which I believe was added in JDK 14. We have the remote recording stream, which was added in 16, I think. Anyway, they work in JDK 19. And the use case I'm going to start with is to monitor our CPU load using a recording stream. So I've stipulated a small problem here. We have a JVM and it takes up a lot of CPU. and we don't know why. And the solution to this is to, when the CPU load is high, we want to dump a JFR recording so we can analyze why the CPU load is high. So we start by creating our small start CPU load monitor method. It takes a path where it should dump the JFR file. We add some sort of logic where we check the CPU load. If it's above a certain threshold, we simply dump the flight recorder stream to a file. We start by creating a new recording stream. We add an event handler to the stream, and this event handler will catch the jdk.cpu load event, which is like a standard event that the JVM comes bundled with. I believe we have like 160 roughly events already in the JVM. We get the CPU load field, and we check it, and then we dump the recording to a file. We also have to enable the event, and you see I enable it here, and I add a period, so we get this event once every second. And you have to enable events explicitly like this when we start a recording stream without an argument. If we didn't enable it, we wouldn't get any events to this stream. It is also possible to load some sort of configuration. In this case, I load the default configuration, and I give that to the recording stream. And with this, you get all the default events in the stream. And then I don't have to enable the event if I don't want to, since I know that the default configuration contains the CPU load event. But I choose to enable it so that I know that we get it every second. And also, since we want to dump the stream to file, I want to get the entire default configuration. If we were to do something else in the CPU load, in case of the CPU load goes high, if we want to send an email or something, then we could just be happy with the CPU load event, and we didn't have to load the entire configuration for this stream. And that is basically it. Oh yeah, we have to start the stream as well. And this start method creates it's a blocking call, so this will just run our event handler and feed it with events. And then when the CPU load goes high, we get a JFR file. And we can take a brief look at what we can analyze using this recording in JMC. We can see the first page, the automated analysis result. We can see that there are some yellow warnings here. We have high JVM CPU load and a few context switches and yaw blocking, so something is weird. We want it to be green on this page. But we go to the event browser. We can, for instance, look at the thread CPU load. We see we have some compiler thread, we have some TCP connection threads and stuff. But if we sort this list on the methods that use the most CPU, we can see that there are a few weird threads in the top. And these doesn't seem to be like JVM threads or stuff, so presumably there is some business service that does something weird. We can right-click here and then store and set as a focus selection. We can enable to show concurrent, which means JMC will show us all the events that are happening in this thread. And then we can go to the thread dump. We can look at all of the thread dumps recorded. And we can see the stack trace of each thread. And then we can find which service was using up all our CPU and blame whoever did that. So this is great. We have our CPU level monitor. We add this to our service and everything is fine. However, we have a small, or a big, should I say, a big cluster of servers. They are containerized and probably some Kubernetes and stuff. And the problem is that these servers disappear because they get closed down by Kubernetes and stuff. And then we lose our lovely recordings. And the solution to this problem is to dump the JFR recordings, move them from the servers and dump them on a more persistent node. So we basically take the streams from the servers and put them on the client. And this is relatively easy to do. We can just take our old CPU monitor, refactor it, and then put this code on the client. So we remove it from the server and put it on the client instead. We refactor it a bit, we add a host, and instead of the recording stream, we take the remote recording stream, and then we do this horrible mess. It's in the docs. I'm not going to explain this. You can read the documentation for connecting via JMX, how you can connect to different JVMs. And we create that connection. We add it to the remote recording stream. We also have to set the max age or max size to the stream in order to not fill up the disk on the client, because now the client has all of the recordings from the server. And yeah, that's basically it. So now we have if we put that code on the client side, the server will move its recording to the client. And I'm just going to show you briefly. I don't want you to look at the details because they're horrible. But on the client side, we just start it. Yes. And on the server side, we have to do like some configuration where we set up JMX. And if we want to have authentication and if we want to use SSL, there will be more properties to add. But it's documented, and just do what the documentation tells you, and yeah, you'll be fine. So now we consumed our events, and now I'm going to show how we can use events in a unit test. And the use case for this that I've come up with is that the finalizers are deprecated for removal, as we all know, so we never write any finalizers. And in order to help us catch finalizers, we have the new JFR event, finalizer statistics, that is emitted for each instantiated class that has a non-empty finalize method. And the problem is that developers of this business logic application keep adding finalizers in their services. And the solution is that we add a mandatory test case to capture all of these events and fail the test. So we start by creating our unit test. We assert that list their classes with finalizers is empty. We have some sort of method that calls all our services, so we get to initialize all our classes and stuff to let the JVM notice that there are some finalizers somewhere. We create a new recording, not a recording stream this time, but we create a new recording. We enable the event that we're interested in. We start the recording, and then we call all our services. We stop the recording, and we dump this recording to a temporary file. And then we take this temporary file and open it using an event stream. And we add the handler, like you've seen before, to the stream that catches the finalizer statistics event. And we get the class that has the finalizer and add it to the list. And we also have to start the stream. And we have to do some nice cleanup. And this is basically the entire test. And yeah, it passes. So our developers were good and did not add any finalizers. And if you are on JDK 19, or for that part, JDK 17 or 11, you can use the recording class. And that's what I recommend. You can use the recording stream. However, the way JFR is designed and it's sometimes hard to know when the stream will end, because we have to wait for the stream to be flushed in order to get all the events. And since we're in a unit test, we want it to be rather quick, so we don't want to wait too long. So it's a bit hard in JDK 19 to use the recording stream. However, in JDK 20, they have added a stop method for recording streams. I tested it and it works excellent, so I can just show you how that test will look using the recording streams. Yeah. So we have the same setup, and instead of a recording, we create a recording stream. We add an event handler, we enable the event, we start an asynchronous, we call this start asynchronous, which will start a thread. So this call won't block. The stream.start will block, but the async will not block. So this will create a thread where we have the event handler and so. And then after we have called all our service, we can just call stream stop, and this will flush the stream and make sure that all of our committed events are added to the stream. And yay, it passes. And with that, we have managed to complete our agenda. You can I have a blog where I write sometimes about JFR stuff, sometimes I write about other troubleshooting things, about JVM crashes and so. You can also see my GitHub where all of the examples are, full examples together with the weird business application. And yeah, follow me on wherever you want to. So, any questions? I can't see anything. Yes?
Is it possible to use recordings to automatically detect certain method calls in your custom code? Or do you have to create custom events to do that?
Sorry, what did you want to catch? Sorry.
I want to basically, similar to what you do with finalizers, I want to check if some methods in my business code are called using the recording. Is it possible?
Well, then your method would have to create an event.
Yeah.
Yeah.
And
so
what would you recommend for testing? Would I have to then create events in my business code?
Yes. Yes.
Okay.
You would have to create like your custom events, and if you don't want to so if I understand correctly, you have a method that you want to know if this is called.
Yeah.
Yeah. So what you have to do then is to this method add the event and commit the event in that method, and then do your tests and check if the method was called. And if you don't want this event to be enabled in production, then you can actually, which I skipped, you can add the enabled annotation, and you can set it to false in your event class, and then basically all of the calls to the event will be no ops. So in production, the event would be disabled, but you can enable it for your test case.
Yeah, great. Thanks.
Yes? Yep.
Thank you. I have two questions. When you started your presentation, the first slide said that the default configuration uses only 1% overhead. But it wasn't clear to me 1% of what? What would be 100% in this case? And second question is if there is any licensing restriction to use Flight Recorder. Thanks.
Yes, thank you. The 1% overhead is like a worst case scenario. You can enable the default recording and you won't notice it. It might add 1% at times, but it's unlikely to add more than that. Or it's guaranteed not to add more than that. It's most likely not adding any overhead, or yeah, anybody. And the second question was if there is any licensing in. No, for JDK 19 and since JDK 11, the Flight Recorder has always been there and freely available. In JDK 8, you had to like unlock commercial features in order to use JFR, but it's but not anymore. Now it's available. Any more questions? Well, I can just give you a small bonus. I can just add some more annotations here, just to have something to say. We can have the data amount, which is data amount, and we can have like memory address, frequency, percentage, and there are lots of other annotations. And yeah, just look at the Java docs and find what you need. You can also add, which I forgot, a description annotation, which can contain a longer description so that everyone knows exactly what the event is for. And the documentation, sometimes when you search for documentation for JFR, you end up on like old JMC versions. That happens to me when I like Google for JFR documentation. You end up at old documentations. My suggestion is you go to, I don't have the URL in my head, but you can go to like the JMC documentation, and from that point you can get to the different JFR documentation for your specific version. Yeah, well, thank you.